Here are the prices for 10 houses in the neighborhood, and you can see most of the houses are in the $130,000 range. And then there's one house that's an outlier. It's a really rundown house. It's only valued at $10,000. So a number that's really far below the data, that's an outlier. And the same if a number is really far above the data, like if there was $1 million house in here, that would also be considered an outlier. But here's where the average can be really misleading. If you average the prices of these homes, add up all 10 values and divide by 10, you would think the average price of a home in this neighborhood is $119,600. So if you went in to buy a home with that budget in mind, you'd be really disappointed when you found out that 9 out of 10 homes are actually out of your price range. They're more expensive than the average. And the only one that's really below or in your price range is so far below, so cheap that it's a rundown bad house that you don't want to buy. So the average is misleading because of that outlier. An outlier will throw off the average. So when we have an outlier that throws off the average price, the median is a much better measure of the center of the data. So let's look at the median for this data. And the median, just like the median in the road, it's the part in the middle. So the median is the middle value in the data. So we're looking for the value in the middle. Since we have 10 numbers, an even amount of numbers, there's going to be 2 values in the middle. So look at those 2. We're going to average them, add those 2 together, divide by 2. The median price of a home is $131,750. So if you use that as your measure for the center of the data instead of the average, you'd have a much better idea of the price ranges for the homes in this neighborhood. And now let's look at another neighborhood that also has 10 houses. And if you find the average price of those houses, add them up, divided by 10, you get the same exact average price. And they also have the same exact median. So 2 pretty different neighborhoods, but the measures of the central tendency are exactly the same. Same average price, same median price. Even though this neighborhood has some houses that are a lot more expensive, it has more cheaper ones, and then it has some in the middle, while this one's mainly all right in the 130s range and then one low one. So that's why it's important to introduce the other topic we're learning about this week, which is variance and standard deviation and range. And standard deviation is probably the most commonly used of those, but those are all ways to measure how spread out the data is. It's not enough just to know what the average price is or the median price is. To really understand the data, you need a measure of how spread out it is. So the standard deviation for this group of houses would be much bigger than the standard deviation for this group of houses, because the data here is a lot more spread out, while here it's all pretty much clumped together in the 130s. So keep that in mind as you're learning about standard deviation. The bigger the number, the more spread out the data is. The smaller the standard deviation, the more together and close the data is.